Today we're going to be talking about confidence intervals for a difference in population proportions. As you watch this video, please be willing to press pause and fill out your notes, answer questions, talk to the people you're watching the video with before moving on. First thing we're going to do is talk about the difference between paired data and two population data. Okay, I've got two examples here. First, to compare whether background noise affects test performance, we decided to recruit 20 volunteers and randomly split them into two groups. Each group takes the same test, and each group has 10 minutes to complete it. Group 1 does it in a silent room, kind of like the ACT, and Group 2 does it in a room where light classical music is playing in the background. Okay, that's scenario 1. Scenario 2, to compare whether background noise affects test performance, we recruit 20 volunteers and randomly split them into two groups. Each group will take the same test twice, spaced 1 month apart. Group 1 will first take the test with no background music playing, and then we'll take it with background music 1 month later. Group 2 will do the opposite. They will first take the test with background music playing, and then take the test with no background music 1 month later. The data collected from which of these scenarios would be considered paired data? This would be a great opportunity to pause, discuss, come up with your answer before I tell you. Okay? Paired data would be this second scenario. Okay? Paired data is when we collect two pieces of data from one individual. This comes from a matched pairs experiment where each person does both treatments. Scenario 1 here is an example of two population data where we have two different groups that each give us one piece of data. Okay. One more time. Now would be a great time to pause and answer that first question on your notes. Describe the difference between paired data and two population data in your own words. Now, when we are working with data from two populations, we're not worried about paired data today. We are worried about two population data. When we are working with paired data, we are going to be using the sampling distribution of statistic 1 minus statistic 2. Today we're focused on proportions. Okay, so let's review what the sampling distribution of p hat 1 minus p hat 2 is going to look like. Okay. First, let's talk about the sampling distribution of just a single sample proportion. Centered at P, the population proportion, if the data come from a random sample or randomized experiment. The spread is the square root of P times 1 minus P over N if the data points are independent. And the shape is approximately normal if the large counts condition is met. The sampling distribution of p hat 1 minus p hat 2 is similar, okay, where the center is now p1 minus p2, again, if the random sample / experiment condition is met for both of our samples. The spread for the sampling distribution of p hat 1 minus p hat 2 is square root of p1 times 1 minus p1 over n1 plus p2 times 1 minus p2 over n2 if your data points are independent for both samples. Lastly, the shape of our sampling distribution will once again be approximately normal if the large counts condition is met for both of our samples. These are the conditions that have to be met to trust the results of the confidence interval. There is a fourth condition that our separate groups must be independent of each other as well. So this independence condition for the standard deviation calculation refers to individual data points being independent from each other, but we also need group independence. Group 1 should not affect Group 2. So let's put it all together and talk about how to calculate an actual confidence interval for population proportion 1 minus population proportion 2, the difference in population proportions. Remember, the general confidence interval formula is statistic plus or minus margin of error, where the margin of error is defined as the critical value times the standard error of the statistic. So, putting it together, statistic, plus or minus critical value times standard error of that statistic. Our statistic is p hat 1 minus p hat 2. Critical value still comes from the z distribution. Standard error of p hat 1 minus p hat 2 is the square root of p hat 1. I don't want to read the whole thing. It's right there on the screen. You can see it. So plugging all of those into our formula, we get this as our formula for a confidence interval. Let's do an example. In a particular school district, there are 2 large high schools. We're interested in the proportion of students at each school who did their homework last night. In particular, we want to know if there's a difference between the 2 schools. To test this, we recruit a counselor from each school. Counselor from school A randomly selects 100 students and finds that 68 of them did their homework last night. Counselor from school B randomly selects 200 students and finds that 101 of them did their homework last night. Our job is to construct and interpret a 95% confidence interval for the difference in proportion of students who did their homework last night between school A and school B. So, first thing we got to do is double check that our conditions are met. Okay? We check the random condition, independence for individual data points, and large counts for both samples, and then independence of the groups. Take a minute, do that. Okay, you should have found that all of those conditions are met. From there, we can calculate all of the different things to go into our confidence interval formula. Plugging that into a calculator, you should get this, a confidence interval of 0.06 to 0.29, okay? The interpretation, take a minute, try and figure that out for yourself, but the interpretation is we are 95% confident that the interval from 0.06 to 0.29 contains the true difference in proportion of students who did their homework last night between these 2 schools. As usual, there is a calculator shortcut. If you go into your calculator, click the Stat button, scroll over to the list of tests. Option number 9, the 2 sample z interval, is what you can use to get this same confidence interval. Okay. I have one more example for you to try. It is written on your notes. Go ahead and take a few minutes, pause this video, try and answer these questions. All right, hopefully you have done that. Answers, our confidence interval is 0.0881 to 0.1235. Interpretation of that interval is we are 95% confident that the interval from 0.0881 to 0.1235 captures the difference in proportions of all U.S. adults who expect to make major sacrifices in their everyday life because of global climate change. To answer part B, yes, we can, how do they phrase it? Yes, there is convincing evidence of a difference in the proportions of all U.S. adults in these age groups who would expect to make major sacrifices in their everyday life because of global climate change, because the interval does not include 0. We think the difference between these 2 groups is somewhere between 8.8% and 12.4%. Any number in between there is what we think the difference might be. None of those are 0. So we believe there is some sort of difference. If our interval went from negative to positive, we would say there isn't evidence that there is a difference in the groups because a plausible value for the difference is 0. And a difference of 0 means there is no difference between the groups. The end.